Hey, hi there, Scott here again. I've got a question from a student about doing ANOVA by hand. So this is where we have more than two groups and we're trying to compare the means of them. So you've got a example of a scientist is testing if type of UV has any effect on the lengths of frogs. So he takes three groups of frogs and exposes them to two types of UV, then a control group. And we're trying to compare at the 5% level of significance whether there's a evidence of difference. So we can formulate our hypotheses. The null is that there's no difference in the means, and then the alternative is that there is at least one pair of means differs. And then we can calculate our test statistic to actually test this. We're comparing we're looking at the between the across the groups variance. So between the first and second, first and third, second and third, and so forth. So we're going to take the between group variation, but then we're going to scale that by how much variation there is inside each group. So for the between group variation, we'll take the group mean minus the overall mean, square it, add together. So that we can take the group means, add together, and then divide by each one. So to get the means, I did that already. For the first group at 9.4286. Then second group, the mean is 9.1429. Third group, the mean is 4. So just the standard mean. And then the overall mean for all the 21 frogs is 7.5238. So we can take for the between group, we take each mean. So we take each mean minus the overall mean and then square it and add that up. We're adding it for each member in the group, so there's 7 of those in each group, so 7 times the first group mean minus the overall mean. And same for the second group, 7 times 9.1429 minus 7.5238 squared. And then same for the third group. And then we're going to divide by the number of groups minus 1, so the between groups degrees of freedom, so divided by 3 minus 1. And that gives calculated 43.556. So that's between variation. So we take each group mean minus the overall mean, square it, add those all up. And then for the within group, we're going to take each element of each group, each value, and then subtract from the mean inside that group, and add all those up for the different groups. So each value minus the group mean squared, and add together. So we take 7, so then the first group is got 7 and 9.4286. We subtract those and square. Then 19 minus 9.4286, square that, and so on for all 7 of those members. And we go to the second group, do the same. 8 minus 9.1429 squared, and so on. And then finally for the third group, we do the same. Each value minus the group mean squared. And then we're dividing by the within group variance, which is the total minus the number of groups. So divide by 21 minus 3. And then that gives the within group variation. I'm getting 6.1428. Great, and so we're ready to calculate our F value. So our F value is the between variation over the within variation. So I'm getting 7.09. And then we can calculate the critical F using, we need the degrees of freedom. So we're going to have the within group, or the between group with degrees of freedom. That's the number of groups minus 1. So 3 minus 1 or 2. And then the within group variance is the total number of frogs minus the number of groups. So n minus k is 18. Then we can come over to StatTrek, use StatTrek, F distribution calculator on StatTrek, and we type in the degrees of freedom and 2, 18, and then 0.95 for the critical value, and then we calculate, and that gives the critical value is 3.55. our critical value is 3.55, and our test statistic is bigger than that, so we reject the null, and we can conclude there is a difference between the groups. And it looks like these first two groups are bigger than this second group, but there is a difference, we conclude. So great, hope that makes sense. Let me know if you have any questions. Otherwise, have a great day.